Hello and welcome to the next installment of my Excel for Statistics video series. If you'll recall, the definition or my definition of statistics uses 5 words. It's the collection, organization, analysis, interpretation, and presentation of data. In this video, we're going to focus on the second of those 5 words, the organization of data. In this activity, we're going to be creating a frequency distribution and then a relative frequency distribution and a cumulative frequency distribution. And then we're going to graph each one of these things. And it turns out that it's very easy to do on Excel. It's going to take a couple of steps, but it's not bad at all. So if you look at that green box on the right-hand side, well, that's our directions here. So column A contains the weight in grams of 70 randomly selected pennies. So if we scroll down, you'll be able to see these numbers go all the way down to row 70. So we have 70 pennies here. So the first penny weighs 2.41 grams. Right? The second penny weighs 2.55 grams, and so on. So what we want to do is we want to organize this data. But the first question, determine if you can observe any characteristics or recognizable patterns in this original data. Now, it turns out, just looking at raw data like this, it's very difficult to see anything meaningful. I mean, we could see everything, every number starts with a 2. Every number is a 2 point something. Right? You can get maybe a little deeper and say, okay, well, there's no 2.1s, 2.2s, or 2.3s, so it looks like everything is between a 2.4 and a 2.99 grams. All right, so that's about all I could see in terms of looking just at this raw data. So what we want to do is create a frequency distribution. Now, I've already given the framework of these distributions. 6 classes with a class width of 0.1 grams. Remember, the class width, we look at the difference between 2 lower class limits from 2.4 to 2.5. That's a difference of 0.1. So the class width, let's write this down here, the class width is 0.1 grams. Okay, so in practice, if you're creating a frequency distribution from your own data, you're going to have to figure out how many classes to use and what the class width is going to be and so on. And that's something I covered in the lecture in class. Okay, so now let's see if we could create the frequency distribution. Remember, the word frequency means count. So to create a frequency distribution, we have to count. And what we're basically doing is we're counting. Let me erase some of this annotation. We're going class by class. So let's start off with the first class. Remember, each one of these ranges is called a class. So the first class is 2.4 to 2.49. So what we have to do is go through this list and count how many pennies there are that fall in that range from 2.4 to 2.49. Not very convenient with these numbers being out of order. I see there's one there, there's one there, let's see, one there, one there. No, this is not what we want to do. Right? I'm going to erase these. We don't want to go down the list of this unsorted raw data. So the first thing I'm going to do is go to the home ribbon and sort these numbers from smallest to largest. Okay, so I could click on the A for column A. That selects everything in column A. And over here towards the right-hand side of the home ribbon, you'll see sort and filter. And in 1 click, 2 clicks, we've sorted from smallest to largest. Now, I'm going to, well, let's start with the 2.4s. Okay, we could see they stop at row 18. So very easy to see there's 18 of them. So over here in the first frequency distribution, in the second column, I'm going to type in 18. Now there's an Excel function for counting. It's actually called equal count parentheses. We don't need to use a function for this. And It's not a function we would use anywhere else in this course, so I'm not going to introduce it now. What I'm going to do, though, is do a little bit of reorganization further than just sorting. I'm going to take all the 2.5s, and I'm going to copy and paste them into the next column. And then we can delete them. The reason I'm doing this is because now it's very easy to see the 2.5s end at row 19, so there's 19 of them. All right, there's other methods for doing the counting. Just in my opinion, this is the one that seems most convenient to me. Then we've got, well, there's no 2.6s, there's only two 2.7s. So what I'm going to do is I'm just going to copy each class up into its own column. I'll highlight all the 2.8s, copy. I'm just using the keyboard shortcut, Control-C and Control-V. And then the 2.9s, let's copy and paste. So now it's very easy to see the frequencies. We see there's no pennies that start with a 2.6. There's two of them that start with a 2.7. There are the 2.8s. Looks like it goes down to row 22. Easy to see there's 22 of them. And the 2.9s, they go down to row 9, so there's 9 of them. And we don't need the 0.00, so we could use these rounding icons here in the home ribbon. And I'll just decrease the number of decimal places down to whole numbers. So there you go. There is our frequency distribution. Now, we'll do the relative frequency distribution next, and you'll see I have it arranged with these two arrows pointing from the frequency distribution to the relative and to the cumulative. That is because, if your goal is to create a relative frequency distribution, you have to first start with the regular frequency distribution. You have to do that first. Or if your goal is to make a cumulative distribution, you want to make the regular distribution first and then convert this to the other two types. Very easy to do. Relative, so let me write this down. It's probably good to note. In statistics, the word frequency means count. I mentioned that a couple of minutes ago. And in statistics, the word relative means percentage. Right? So to create a relative frequency distribution, all that means is we take the frequencies and convert them to percentages. So percentage is a ratio of part to whole. The whole group, we know there's 70 pennies. There's 70 numbers in our original set. So what we have to do is take each one of these numbers and divide them by 70. So over here in the first in that first blue box, the relative frequency for the first class, I'm going to have Excel calculate the percentage. So I'll type an equal sign, and I want this number in H9 divided by 70. I'm not going to type 18 divided by 70 because if I do that, then on the next cell I have to type in manually 19 divided by 70, and then 0 divided by 70, 2 divided, and so on. Repetitive calculations. We're doing the same calculation 6 times. We're taking each number, dividing it by 70. So let Excel repeat it the next 5 times. Okay, we discussed this in the previous video, how to have Excel repeat a calculation for you. Hover the mouse over the bottom right-hand corner of that cell where you typed in the calculation first yourself manually. The little white plus sign turns into a black plus sign. Click and drag. And Excel took the next number divided by 70, then the next number divided by 70, and so on. And the directions say take those relative frequencies and instead of decimals, express them as percentages rounded to 1 decimal place. Okay, so what I'm going to do is go back to the Home tab, and right in the middle, you'll see the word number and an arrow for a drop-down menu. That gives us a whole bunch of different options to display the number in. And what we want to use is percentage. So I'm going to highlight everything I want to turn to a percentage, and using this drop-down menu, convert to percentage. The directions say a percentage to 1 decimal place, so I'm going to go back to the decrease decimal icon. And there are our relative frequencies. We just took each frequency and divided it by the sample size. In this case, 70. We took each frequency and divided by 70. Okay, the cumulative distribution is a little bit different. You'll see that the classes are different than the original frequency distribution. The frequency distribution and the relative frequency distribution have the same classes. Cumulative, and we're going to use this term later also in the semester, so let me give it a little bit more space. In statistics, the word cumulative means a running total. A running total, or adding up everything from the beginning. So you'll see the first class in the cumulative frequency distribution is everything up to 2.49. Well, that's going to be the first class. And then the second class, everything up to 2.59, well, that's going to be the first 2 classes added up. Right? Everything up to 2.69 is going to be the first 3 classes added up, and so on. All right, so that's what we're going to do. For the first class, that's just going to be equal to the 18. But for the second class, I want to add 2 cells, so I'm going to use the sum function, equal sum, and I'm just going to highlight the first 2 numbers and enter. Next one, equal sum, and I'm going to take the first 3 classes of the frequency distribution. Still 37 because we added a 0. So basically the first class is 18. The next class is 18 plus 19. The third one is 18 plus 19 plus 0. Running totals. The fourth one is going to be the first 4 classes added up. So equal sum. I'll highlight the first 4. Next, we're going to add 22 more. So that's all 5 classes, equal sum. And I'll take the first 5 frequencies. And finally, everything up to 2.99, that's going to be everything. So equal sum of all 6. And this should give us 70 because it accounts for all members of the sample. And we could do the same thing as before. We could get rid of those 0.00s. We don't really need those. All right. So now we've got our relative frequency distribution. Relative means percentages. We've got our cumulative frequency distribution. Cumulative means running totals. Now, if we look at question number 3, has our answer to number 1 changed? So based on this organization that we just did, now can we recognize any more or additional characteristics or patterns in the data? And at this point, I would say yes, absolutely. So if we look at this frequency distribution, let me zoom in a little bit on this, just the frequency distribution. It looks like we've got a group of pennies on the low end between 2.4 and 2.59, or we could say 2.4 to 2.6, just to round it out. Then we've got some more pennies on the high end, the 2.8 to 3. So it looks like within this group of 70 pennies, we've got some that are lighter, and we've got a completely separate group that are heavier with a little bit of a gap in between. So I did a quick Google search to figure out why this might be true, and what I found out was in 1982, the recipe for pennies changed. Right, in 1982, the federal mint started using less copper and more zinc, because zinc is cheaper than copper. It costs less. So in 1982, the mint changed the recipe. So the weights of pennies changed. Right, so we have a group of pennies from before 1982 and a group of pennies from after 1982. I can't remember which one is the lighter one or which one is the heavier one. I think the copper would be the heavier one, but I'm not sure. Either way, we have a distinct group from before 1982 and a distinct group from after 1982. And this was very difficult to see when we were looking at just that one single list of unsorted data. Okay, so that's it for the frequency distribution portion of this video. Now I want to talk about the graphs, and this is going to be much quicker. This is really easy to do. So we want to make a graph of the frequency distribution and a graph of the relative frequency distribution. Right, these are called histograms. Then we want to make a graph of the cumulative frequency distribution. This is called an ogive. So I put a couple of orange bars. We're gonna make the frequency we're gonna make the histogram here. We're gonna make the relative frequency histogram here. We're gonna make the ogive down here. Okay. Graphing in Excel, very easy to do. Let me get rid of some of that annotation. You want to first highlight what you want to graph. So I want to highlight the classes and the frequencies. And in the insert ribbon, all we need to do is pick the little icon that looks kind of like the graph you want. So a histogram is a bar chart with no gaps between the bars. So this looks like an option, and yeah, there we go. It's not exactly a histogram, but we could make a couple of changes here. Okay, I'm gonna move it over to some white space so you can see exactly what I'm doing, and then we'll move it back once it's finished. Okay, a histogram is a bar chart with no gaps between the bars. So what I'm going to do is I'm going to click on one of the bars. So now you see they're all highlighted. These little circles on the corners of each bar tells me that they're highlighted. And then I'm going to right click on any one of the bars. Doesn't matter which one. And I want to format the data series. Right? Format means change, edit. I just want to make some edits. So format data series. And the first thing you'll see let me do that one more time. Oh yeah, okay, yeah. When you click on one of the bars, there it is, right there at the bottom, gap width. We want 0 gap. So we could just make that little slider, or move that little slider all the way to the left so it's a 0. And there you go. A very ugly histogram. Right, the bars sort of blur into each other because it's just a solid blue with no separation. So remember, one of the things I mentioned in class was that you never want to really make any aesthetic changes to your graph unless those aesthetic changes make it more readable. And so one thing I always do when I make a histogram on Excel is under Fill. Let me click on the graph one more time. Under Fill, I just click this one box right here, Vary Colors by Point, and making that one small change, it's a much easier to read graph. All right, so it's a much less ugly histogram. And one more, I'm only going to do one more thing. Maybe let's do two more things. One, let's add some labels. So whoever is reading this, or whoever we're presenting this to, knows what all these numbers mean on the axes. So I'm going to hit this plus sign, and I'm going to check off the box next to axis titles. So now I could add some axis titles. Let's call this one, you can call it whatever you want. Let's call it weight in grams. And on the other axis title, let's just call that frequency. And under chart title, we can edit all these. Let's call this, I don't know, 70 pennies histogram. And now it's kind of white background on a white background. So the last thing I'm going to do is go to the home ribbon, and under fill color, let's just do a nice, maybe, a light purple, just to make it pop. All right. So a couple of aesthetic changes, and it looks like it's a much nicer histogram. All right. You're not going to learn all the different editing tricks in this video, not by a long shot. That's not the point. The point is just a quick introduction, and it really takes just messing around with it on your own. All the, you could do shading and sparkles and three-dimensional and, shadows. There's all kinds of stuff you could do. I never do any of those things because none of them add to the readability of the graph. Okay, next one, relative frequency distribution. I'm going to do the exact same thing. I'm going to go through this much quicker. Highlight, insert tab, pick a little icon that looks like what I want. Okay, I'll click on one of the bars, format data series, change the gap width. I'll go to fill, vary colors by point. I'll go to the home ribbon, put a little purple background, make it pop, and then finally I'll add some axis titles. I'm going to use the same for the horizontal. Let's call this weight. Ooh. In grams, we could get rid of that. Let's call this 70 pennies. Relative histogram. Yeah, we can make them about the same size. Oh, forgot the axis title. On the vertical axis, let's call this relative frequency, and there we go. It's really nice. Like if you're writing a paper, if you make a quick graph in Excel, you could just copy and paste it right into a Word document. It adds a lot with not too much work in terms of the, just the aesthetics of a paper. So it's not just text. You could add some graphs, and you could wrap the text, you could wrap the graph tight with the text, so you can move it around and the text will sort of go around the graph. You can do all kinds of stuff. All right, the last one, the last question, number 5, is an ogive. So we don't make a histogram of the cumulative frequency distributions generally. You can. But we use what's called an ogive graph, which is it's basically just a frequency polygon that's used for a cumulative frequency distribution. So a series of points connected by lines, and that's it. So we'll go insert. The line graphs are here, and I'm going to pick the one with the points, and yeah, there it is. That's an ogive. A point for each of the cumulative frequencies. connected with line segments. So we'll call this one "70 Pennies Ogive Graph." Nothing too fancy there with the title. Let's make that purple. Add some axis titles. And I'm just doing exactly what I did in the previous two graphs. And there is our ogive. I'm just going to move it down to where it's supposed to go. The last thing I want to point out is notice the graph, the histogram of the frequency distribution and the histogram of the relative frequency distribution are identical. The graphs are identical. The only difference is the labeling on the vertical axis. So on the left-hand side, the left-hand graph, the vertical axis is labeled in counts, the frequencies. Oops, didn't mean to do that. And on the graph on the right-hand side, the vertical axis is labeled as percentages, percentage of the sample. Okay, that does it for this video. Organization, and so the frequency distribution, the first part, creating these three frequency distributions and reorganizing the data, that was the organization step. And then these three graphs down here, these fall under the last of those 5 words: presentation of data, collection, organization, analysis, interpretation, and finally presentation of data. I made a couple of edits. I did a purple background. I varied the color of each bar. Both of those things really added to the readability of these graphs. Okay, that is it for this video. I'll see you in the next one.